Good afternoon, guys. Welcome back into my channel. So in this lab and lecture, we're going to configure EtherChannel. But the main reason of this lecture is to understand in depth what is EtherChannel. So this here is a PDF file of the CCNP and CCIE Enterprise Core Encor 305-401 official cert guides. So you see here it says EtherChannel bundle. Internet network speed are based on power of 10 gigabit per sec. 10 megabyte per second, 100, 1 gigabyte, 10 gigabit, and 100 gigabyte per second. So when a link between switches becomes saturated, how can more bandwidth be added to that link to prevent packet loss? So it says here, if both switches have available port with faster throughput, then the current link, for example, 10 gigabit per second versus 1 gigabit per second, then changing the link to the higher speed interface solves the bandwidth contingency problem. However, in most cases, this is not feasible. Ideally, it would be nice to plug in a second cable and double the bandwidth between the switches. However, the spanning tree will place one of the port into a blocking state and prevent forwarding loops, just like you're looking at here in this architecture. So it says, fortunately, the physical link can be aggregated into a logical link called an EtherChannel bundle. The industry-based term for an EtherChannel bundle is channel and is EtherChannel for short, or port channel. This is defined in the IEEE, IEEE 802.3AD link aggregation specification. It's physical interface that are used to assemble the logical EtherChannel are called member interface. So STP operates on logical link and not on a physical link. The logical link would then have the bandwidth of any active member interface, and it will be load balanced across the link. EtherChannel can be used for either layer 2 access or trunk or layer 3 routed forwarding. So note, the term EtherChannel or EtherChannel bundle or port channel are interchanging frequently on the Catalyst platform, but other Cisco platforms only use the term port channel exclusively. Now, this is different architecture and lecture here. So as we say, we're going to leave a link of this PDF book for free. So if you want, you could always give us a donation, but if not, you could just, you have the privilege to own this book. So if you, wanna take the time to take a look at it and see what you can learn from this book. So the little lecture I prepared here based on this book is that let's start from here. So understand EtherChannel technology. So in most network design, network administrators connect multiple physical Ethernet link between devices to achieve more bandwidth and redundancy. So with this, the links get blocked to prevent switching loop by the spanning tree protocol. For this reason, we need a technology that will allow redundant link that the spanning tree protocol will not block. So this is where the concept of EtherChannel technology and its configuration will help handle this with ease. So guys, the prerequisite, so the reader must observe the following prerequisites. You have to have a good understanding and basic networking concept, a good understanding of how to configure switches using packet tracer. So what is EtherChannel technology? So EtherChannel is a link aggregation technology that makes it possible to combine several physical links between switches into one logical link to provide high-speed link and redundancy without being blocked by the spanning tree protocol. So there is a provision of fault tolerance, load balancing, increased bandwidth, and redundancy formed through negotiation with two protocols: port aggregation protocol, which is PAGP, and link aggregation control protocol, which is LACP. Now, EtherChannel terminologies: EtherChannel, a port channel architecture that groups together multiple physical Ethernet links into a single logical link that provides fault-tolerant, high-speed, redundant link between switches and other network devices. So spanning tree is a data link layer protocol that prevents loops in networks with redundant links. Port channel, this refers to communication link between switches that combine multiple Ethernet ports bandwidth into a single logical link. So channel group is a collection of Ethernet interfaces on a single switch. Now, EtherChannel technology protocols. So port aggregation protocol, which is PAGP, is a Cisco-based protocol and runs on vendor license switches that support PAGP. It facilitates the automatic creation of Ether channel links by detecting the link configuration on each side and ensuring the link are compatible for forming an Ether channel link. So it works in 3 channel modes. First, on NFS, in this mode, there is no exchange for PAGP packets. Second, desirable mode interface negotiate with each other by sending PAGP packets. And the third, auto here interface respond to PAGP packets but cannot start a negotiation with other interfaces. So note, an Ether channel to form the mode must be compatible on either side of the link. The table below shows different mode combinations that can form Ether channel link. Let's say switch 1 is on, switch 2 is on. So the Ether channel formation is yes. But if switch 2 is on, if switch 1 is on and switch 2 is desirable or auto, then the Ether channel formation is no. If switch 1 is indesirable, then switch 2 is indesirable or auto, then the Ether channel formation is yes. So follow on, if switch 1 is in auto and switch 2 is indesirable, then the Ether channel formation is yes. So last but not least, if switch 1 is in auto and switch 2 is in auto, then the Ether channel formation is no. Now, the link aggregation protocol, LACP, is like the PAGP protocol, but it It is an open standard protocol that facilitates EtherChannel configuration in multi-vendor environments. Not limited to Cisco switches only, it allows both, active links and standby links. It works in 3 modes. One, on interfaces, on this mode, there is no exchange of LACP packets. The second is link interface active mode interface negotiate with each other through the sending of LACP packets. So 3, passive here interfaces respond to LACP packets received, but cannot start a negotiation with other interfaces. So there go the table for the LACP. If switch 1 is on, switch 2 is on, the interchannel information is yes. It goes on, switch 1 is on, switch 2 is active or passive, then it's a no. If switch 1 is active, switch 2 is active or passive, then it's a yes. If switch 1 is passive, switch 2 is active, then the EtherChannel is yes. Then last but not least, if switch 1 is passive, switch 2 is passive, then the EtherChannel formation is a no. Now, note, the reason I put this in green is that you may pay careful attention to this. So active links are the EtherChannel links currently transmitting the traffic when one of the currently active links goes down, the standby link become active and takes over. So EtherChannel network configuration. Now, this is a topology. If you wanna, take a look at this yourself, you could. I go different. They go different configuration command that I put together for you. Now, let's go on the conclusion here and start doing the lab configuration for this. Now, guys, so that's if you want to troubleshoot EtherChannel. So with this conclusion here, says as we have seen, EtherChannel technology is convenient for increasing our bandwidth and redundancy in our network without the redundant link being blocked by the spanning tree. So the summary is that we learned that EtherChannel technology, so these are the things that we learned. So let's go ahead and pull Packet Tracer and start our lab today to configure EtherChannel. So the lab objective says that in part 1, configure basic switches settings. Part 2, configure the EtherChannel with Cisco PAGP. Part 3 is to configure the 802.3AD LACP EtherChannel. Part 4 is to configure a redundant EtherChannel link. So there go the port channel table. That's what we have here, channel group, ports, protocol, and there go the instructions. So why don't we go ahead and start? Sorry, guys. Why don't we go ahead and start this configuration, as that was the purpose, but then what's most important is not just to pull up and start making a configuration, but it's to make you understand the deep meaning of these things. Because you not only need the knowledge to pass the the Cisco certification, but you only need it also for life. So conf t, let's change this for switch 1. Okay, so now we could say show. Let's go ahead and exit. Exit. And we could do, say, show interface pipe include Ethernet. See if it give it to us. Let's make this capital and save them. This will make a difference. Okay. So you see here, so before begin the link aggregation between switches, verify that the existing configuration of the port that connect the switches to ensure that the port will successfully join the EtherChannel command. So this command that we use is just to verify all these ports. So the ports, they're gonna provide the information about the states of the switch port include. So let's try this different command again. Let's grab this, say show. Paste. So see all these ports not connected. Let's try this different one here. And then space it. So now it says configure all ports that are required for the EtherChannel as static trunk port. So it says note, if the ports are configured with DTP dynamic auto mode and you do not set the mode of the port to trunk, the link do not form trunk and remains access ports. The default mode on the 2960 switch is for DTP, which is dynamic trunk protocol, to be enabled and set to dynamic auto DTP can be disabled on interface with the switch port non-negotiation. So let's see here. It says part 2, we're going to configure the channels. So let's go ahead and do this. This. Let's give us anything. Okay. So show interfaces trunk. So the first list that is created on this aggregated and use the song command to ensure that okay. So let's do on switch 1 and 3, we're going to add the fast Ethernet. Okay, so let's do conf d, then end interface range f0/1, f0/21. So that's what we give here, right? Let's just copy this. No, I can't. So f0/21 to 22, right? Then we could do shutdown. And we do channel. Let's exit out. We could do channel group 1 mode desirable. Then we could do no shutdown. Now let's go ahead and do that on switch 3 too as well. So as you can see here, that's on switch 1. Let's do it for switch 3. Let's go ahead and do this. Face range 0/21 to 22. Right. See shutdown. What am I doing? 22. Say shutdown. Up. Then we could do channel. Say group. Oh, sorry, channel group 1 mode desirable. Okay, then we could say no shutdown to open it. Now, you're gonna get the message creating the port channel interface. Port channel 1 should appear on both switches when the channel group is configured. So now let's configure the logical interface to become a chunk by first entering the interface port channel number. Let's go on switch 1. Let's do interface. Oh, let's exit out 1. Says interface port channel 1. Then we could do switch port mode chunk. And then let's do that also on switch 3. So you see now we started to have a green light. So we in this we on this we so far so good. So it says interfaces port channel 1 switch port mode chunk. Typo chunk. Now, in step 2, we're going to verify the port channel status. So let's could do that, do show EtherChannel, say some, see if it take this. Right. So you see here it says the flag is down. So we port standalone, suspended, LACP only, number of channel in use is 1, and the number of aggregator is 1. So let's go ahead and do the same. Oh, erase forward. I don't know. It's to do show eat some. So here, so far so good. Now, if the ether channel does not come up, you could have shut down the physical interface on both ends of the ether channel and then bring them back again and do the show interface trunk and show spanning tree command to show the port channel as one logical length. So now we already do 2 parts so far. So we done the configuration and the basic setting switches, and we done this part. So now let's do this part here. Part 3, it says that we have to configure an 802.380 LACP ether channel. Now, in 2000, The IEEE released the 802.380, which is an open standard version of EtherChannel. It is commonly referred to as LACP, using the previous command to configure the link on switch 1, switch 2. Now, let's go ahead. So I'm on switch 1 already. Let's go ahead and do, so exit. Let's do interface, range, gig, 0/122. We could do shutdown. Then we could do channel, channel group. Does it take it? So channel group 2 mode active. Then we could do no shutdown for that. Then we could do interface. We could do interface port channel 2. Then we could do switch port mode chunk. See if we have it. Chart mode chunk. Now let's do that on switch 2 as well. Oh, I've been working with switch 3 as if it was switch 2, but that's okay. So let's do that on switch 2. So and conf t switch 2. We could do and range gig 0/122. Right. We could do shutdown, and we do channel group 2 mode active. Then what else we do? No shutdown. Then we do interface. Oh, this one is not gonna let you press tab to autocomplete. So port channel 2. I say switch port mode active. I mean switch port mode chunk. Okay. So now, if we go to switch 1 and execute this command to show it some. Now you could see here that the channel is changed from 1 to 2. Remember the started port, the channel port now is no longer 1 but 2. So now we've done with this part. Now the fourth part says that to configure a redundant EtherChannel link. So why don't we go ahead and do that? Let's pull switch 2. What is it? Let me change this to switch 2 and exit out and call this host SW2. Okay. So say interface range 0/23 to, so that's what we had and that's what we work with. Okay. So 23, 24. Let's do channel group 3 mode and the core interrogation question mark. So you see it says active, auto, desirable, on, passive, just like we explained in the lecture earlier. Now, on switch 2, we can add fast Ethernet 0/23 and 24 to for channel 3. Let's go ahead and do that. Say no, shut down. Now we do channel group 3 mode passive and we'll shut down to interface port for channel 3 switch port mode chunk. Okay. Now on switch 3, all the ports on switch 3, all the ports F0/23 and 24 to port channel 3 with the channel group 3 mode active. So the active option indicates that you want the switch to use LACP and conditional statistically configure port channel 3 as a chunk interface. So let's go ahead and switch to, as we already here, let's do exit out 1, let's say do show eat summary. Now you can see it says the number of group in use is 2. The number of aggregator is 2. But in the bottom here, you see where it says the LSCP thing is. Now, creating an EtherChannel link does not prevent spanning tree from detecting switching loops. View the spanning tree status on the active port on switch 1. Let's go on switch 1. Let's say exit 1, go show spanning active. So port number 2 is not operative because spanning tree protocol placed some port into blocking mode. Unfortunately, these ports were the gigabit port. So in this topology, you can restore these ports by using switch 1 to be the primary route for VLAN 1. And you could also set the primary to 24/576. So I'll go ahead and do that. So let's say spanning tree VLAN 1 root primary. So you may also have to wait for STP to recalculate the tree topology, or either you could press forward in if necessary. But now all the interfaces support the EtherChannel up to a maximum of 8 NFSs with no requirement that the NFS be on the same NFS module. And again, all the NFSs within an EtherChannel must operate at the same speed and duplex. And EtherChannel link can function as either single VLAN access port or a chunk link between switches. See now. And all interfaces in the layer 2 EtherChannel must be members of the same VLAN or to be configured as trunk. If configured as link, as trunk link, layer 2 EtherChannel must have the same native VLAN and have the same VLAN allowed on both switches connected to the trunk. Now, when configuring EtherChannel link, all interface should be shut down prior to the beginning of the EtherChannel configuration. When configuration is complete, the link can be re-enabled. After configuring the EtherChannel, verify that all the interfaces are in up state. It is possible to configure the EtherChannel as static or for it to use either PAGP or LSCP to negotiate the EtherChannel connection. The determination of how an EtherChannel is set up is the value of this channel group, number, mode, command, valid values are. Active LSCP is enabled unconditionally. Passive LSCP is enabled only if another LSCP capable device is connected. Desirable PAGP is enabled unconditionally. Auto PAGP is enabled only if another PAGP capable device is connected. So the own EtherChannel is enabled, but without either LSCP or PAGP. Now, LAN port can form an EtherChannel using PAGP if the mode or compatible PAGP modes are desirable. So more than equal to desirable. Desirable more than equal to auto. If both NFSs are in auto mode, an EtherChannel cannot form. Now the LAN, I'm pretty sure that was long of a lecture, but that was super helpful. So please subscribe to my channel for more of lab like this. Thank you so very much. I appreciate you guys was following along. Stay tuned for another lab.